Imagine a world where data is the new gold, and you could be the one to hold the key to unlock its endless possibilities. In today's rapidly evolving technology landscape, data engineers are the architects of this new frontier. But how do you become one of these most sought after experts? In this video, we will unravel the secrets behind becoming a top tier data engineer. We will uncover what data engineering truly is, why it is such a hot career choice, and who it is perfect for. And that is not all. Stay with me as I delve into the ultimate roadmap that will transform you into a skilled data engineer, step by step, in a period of 6 months. I'll keep it simple and focused, cutting out the jargon and unnecessary fluff. You won't need to learn hundreds of irrelevant technologies, but follow a well-scoped and structured learning path to deliver wonders in a few months. Before I begin, I'm Deepanshu with 18 years of experience working in data. I'm an ex-Microsoft and a certified data engineer with plentiful of experience implementing data solutions across Azure, AWS, and GCP. So roll up your sleeves and get ready to dive into the world where data meets engineering and find out why this might be the coolest job you ever knew you wanted. This video is divided into two sections. The first section, I will demystify what, why, and who the data engineering is for. Section 2 is all about how, where I will share a tailored 5-step roadmap that sets you for a successful career in this highly paid role. First thing first, what is data engineering? In simple terms, data engineering is the process of designing, developing, and managing the data infrastructure. This infrastructure lets you collect any type of data from anywhere. It makes provisions to store that data, allows you to transform that data, and making sure that it is accessible and ready for analysis by either data analysts, data scientists, or other business applications. A modern age data engineer must understand that data not only lies in a structured or tabular format, but also comprises of completely unstructured forms of data such as video, audio, and the recent content that you would have posted on your Instagram and image. Modern data engineered solutions don't wait for 8 hours before I am alerted about my credit card payment that happened a few seconds ago. It allows for these important updates to flow in real time on my mobile, then taking hours. Modern data engineering requires you to understand appropriate technologies to store these different types of data formats. For instance, using Oracle or SQL Server to store structured tabular data, MongoDB to store a JSON document, and a data lake for unstructured data like videos and images. Finally, data engineering is all about transforming all this data and making it available for any analysis. Here's a view of key responsibilities of a data engineer, so pause the video and digest it. In essence, data engineering is a critical role that is about making data useful and accessible for all. Now that we understand what data engineering is, let's dive into why you should consider pursuing a career in this field. The demand for data engineers is consistently growing, and there are several compelling reasons to join this exciting industry. According to recent market data, job postings for data engineers have grown by over 50% in last 2 years alone. Companies across all sectors are investing heavily in data infrastructure, driving the need for skilled data engineers. By 2025, the global volume of data is expected to exceed 180 zettabytes, according to IDC. This explosive growth means that organizations will need more data engineers to manage and harness this data effectively. The average salary for a data engineer in the United States is around $120,000 per year, and in major tech hubs, it can go even higher. So to sum it up, pursuing a career in data engineering is not only timely, but it is also rewarding. The high demand, competitive salaries, diverse applications, and opportunities for growth make it an excellent choice for anyone looking to build a future-proof career. But who is data engineering for? Let us break it down. Data engineering is perfect for those who want a more sophisticated, challenging, and of course rewarding career than data analysts. Additionally, data engineering doesn't require you to have a specialized degree in mathematics or statistics like a data scientist. And that makes it a perfect sweet spot for many. In summary, data engineering is for those who have a passion for data and enjoy programming than avoiding it. So make your choice. Now let's talk about the most important part, how to become a data engineer. I designed a comprehensive and your ultimate roadmap that will guide you through the entire process of becoming a skilled data engineer in just 6 months. This roadmap is broken down into 5 key steps, and here they are. We start by talking about technologies that help you build a strong base in data engineering. Then we move to embracing cloud, that is the cornerstone of modern data engineering. Third step is learn some essential and popular third-party and open source technologies. I then leave you with resources to apply your skills through real-world projects to build your portfolio. And finally, my advice on navigating the job market to land your first data engineering role. This step is all about building a strong base with the essential skills that you will need as a data engineer. I will break it down into 2 key areas: data stores and programming languages. Data stores includes 3 key data storage technologies that you need to learn, and they are relational database and data warehouse for tabular or structured data, NoSQL databases for semi-structured or documented data, and finally data lakes for unstructured data like videos and images. First up, understanding how to design, query, and manage databases is a crucial skill for a data engineer. You will need to be comfortable with both relational databases and data warehouses. Note the difference between the two. While relational databases are for online transactional processing or OLTP type of workload, data warehouses are mainly for online analytical processing or OLAP in short. To further simplify, OLTPs are designed for heavy transactional types of systems that are optimized for frequent data updates, like recording all transactions from an e-commerce website. OLAP, on the other side, are designed for more data analysis purposes, where their schema is more optimized for faster read operations over a huge amount of structured data. Popular relational databases include SQL Server, Oracle, MySQL, and many more. Similarly, some of the popular data warehouses include Snowflake, Azure Synapse Analytics, Amazon Redshift, and Google BigQuery. To learn about foundations of relational databases, I recommend that you follow this link to database design course from FreeCodeCamp. While for learning basics of data warehouses, use this playlist that comprises of series of videos, and I have shared the link for both in the description box. Now the next data store to learn is NoSQL database. NoSQL databases are different from relational databases in a way that they're designed to handle large volume of unstructured or semi-structured data, making them ideal for big data applications. They are built using distributed computing. And unlike traditional relational databases, NoSQL databases are flexible, scalable, and can manage diverse data types, from documents to key value pairs. Popular NoSQL databases include MongoDB, Azure Cosmos DB, Amazon's DynamoDB, and Google's BigTable. They all allow you to store data in flexible JSON-like documents. And these databases are essential for modern data engineering that allows for efficient data storage and retrieval across distributed systems. Now you need to get your basics of NoSQL database right. I recommend you watching this 3-hour-long course from FreeCodeCamp, and you can find the link in the description box, and this would set you good for now. Now, data lakes. Data lakes are centralized repositories that allow you to store all your structured, semi-structured, and unstructured data at any scale. Unlike traditional databases, data lakes enable you to ingest any amount of raw data without needing to transform it first. And this flexibility allows for the more comprehensive real-time analysis of the data. And key players in the data lake arena include AWS's S3, Azure Data Lake Storage, and Google's Cloud Storage. They provide scalable, secure, and cost-effective solution for big data analytics. To get your foundations of data lakes covered, I recommend you watching this video, and I've included the link in the description box. SQL, or Structured Query Language, is the backbone of data management in relational databases and data warehouses. It allows you to query, manipulate, and manage data efficiently. With SQL, you can perform operations like retrieving specific data, updating records, and joining tables to extract meaningful insights. So mastering SQL is crucial for any data engineer, as it is widely used in various data platforms like MySQL, PostgreSQL, and SQL Server. Best resource to learn SQL is this book titled Beginning SQL. I've read this book many years ago and it is still the best. So go through the entire book comprising of 13 chapters and you will be settled with SQL for the rest of your life. Next programming language to learn is Python. While many would tell you to go for a number of other programming languages like Scala, Java, I would say just learn Python. Once you have a grasp of Python, you can pretty easily adopt to PySpark to deal with big data systems that are built over Apache Spark like Databricks. And best resource to learn Python is this full Harvard University course, and you will find the link in the description box. Additionally, if you are more into reading than listening, I would recommend this official Python tutorial page. And that concludes our step 1, and I expect you come out building your foundation strong. Welcome to step 2 of our data engineering roadmap. In today's data-driven world, practicing and learning data engineering on cloud is not just an advantage, it is essential. Why is the cloud so important? Because the sheer volume of data that organizations need to process is growing exponentially. On-premises solutions simply can't handle the scale, speed, and complexity required for modern data engineering. Cloud platforms provide the flexibility, scalability, and the cost effectiveness needed to process large dataset efficiently. Here, let us look at the 3 leading cloud providers: Amazon Web Services, or AWS, Microsoft Azure, and Google Cloud Platform, or GCP. Each offers powerful tools and services for data engineering. Starting with Microsoft Azure, I would highly recommend that you follow a structured approach by following Azure's Data Engineering Associate certification. I don't want you to get lost into what to learn and how much of it to learn. So to draw the clear scope, you should begin by first completing Azure's Data Fundamental, which is DP 900 course, followed by the Azure Data Engineer Associate, which is DP 203. While DP 900 would give you a strong foundational understanding of key Azure data-related services, DP 203 would go into great details about a number of services including Azure SQL, Synapse Analytics, Azure Data Lake, and Databricks. Through this learning path, you will develop skills to ingest batch and real-time data. You will learn to build data pipelines for data transformation. Moreover, you would also get a broad understanding of your responsibilities towards data security and governance. Link to the learning path for both courses are included in the description box, so please get it from there. Now similarly, for AWS, you are advised to follow Data Engineer Associate learning path. This would include technologies such as RDS, Redshift, S3, Amazon Glue, and much more, which are essential for any data engineer to know if they work on AWS. For GCP as well, I would recommend you follow official learning path for their Professional Data Engineer certification. This would cover all core data engineering technologies such as Cloud SQL, BigTable, Cloud Storage, and Data Proc, and much more. By leveraging these cloud services, you can handle data at scale, perform complex queries, and derive insights faster and more efficiently than ever. The cloud also offers robust security, reliability, and disaster recovery capabilities, ensuring your data is always safe and accessible. Following the official cloud provider's learning path would also help you to potentially get certified, and that would definitely add value to your resume and increase your chances of landing your next role faster. Welcome to our step 3 of our data engineering roadmap that talks about important third-party services and as well as open source services. While mastering core data engineering platforms of cloud provider is essential, it is an advantage to also learn about popular, latest and greatest technologies in the space of data engineering. First up, Snowflake. It's a very popular cloud data platform that offers a scalable, performant, and enterprise-grade data warehouse. It is very well adopted by many Fortune 500 companies. And as data engineer, it would definitely be an advantage if you have familiarity with it. Second technology is dbt. dbt is an analytics engineering tool that enables faster data transformation along with widely adopted data warehousing solutions such as Snowflake. It allows you to write modular SQL queries to transform raw data into analysis-ready datasets. It's a great choice for organizations that are looking for a cloud-agnostic data transformation solution to avoid lock-in. Third technology is another open source technology called Apache Airflow. It's a platform to programmatically author, schedule, and monitor workflow that make it easier to manage and maintain complex data pipelines. Airflow provides great scalability and is highly extensible with a rich ecosystem of plugins and integrations with various data tools and services, including across the cloud providers. Hands-on projects are crucial for solidifying your knowledge and demonstrating your skills to potential employers. Here are some resources and project ideas from AWS, Azure, and GCP to get you started. Starting with Azure, I recommend you create an Azure free account to access popular services for free for 12 months. It gives you a USD 200 worth of credit for the first 30 days. For the project, follow this video that guides you to implement a fully functioning project leveraging many services such as Azure Data Lake, Data Factory, Databricks, and Synapse Analytics. Similarly, for AWS, use the AWS free tier to get hands-on experience with various AWS services without incurring costs. And afterward, use this video guide that takes you through a real-time project implementation using key AWS services such as S3, Amazon Glue, Athena, and Lambda. And finally, on GCP as well, take advantage of the Google Cloud free tier, which includes USD 300 worth of free credit that you can use over 90 days. For the project, refer to this video guide that implements a real-life project using key GCP technologies such as Cloud Storage, Cloud Data Fusion, Airflow, and BigQuery. Completing these hands-on projects would help you build a strong portfolio for your resume and make you stand out among others. And with that, we will move to the last and important step in this journey. Here are some best practices to help you stand out in the job market. Firstly, build your portfolio. Showcase your projects on platforms like GitHub and create a personal website to highlight your work and skills. It is very easy to do. Networking. Join data engineering communities, attend industry events, and connect with professionals on LinkedIn. Networking can open doors to job opportunities and provide valuable insights. Next, certifications. Earning certifications from AWS, Azure, and GCP can validate your skills and make your resume more attractive to employers. So consider respective certifications of cloud providers in the domain of data engineering. Then tailor your resume. Remember to customize your resume for each job application, emphasizing relevant skills and experiences. Use keywords from the job description to pass through applicant tracking system. Preparing for interview. Practice common data engineering interview questions and be ready to discuss your projects in details. Remember, landing a job in data engineering is a journey. By working on hands-on projects and following these best practices, you will be well on your way to securing a role in this exciting field. With that, thank you for joining me on this comprehensive data engineering roadmap. I hope you found the content useful, and I wish you best of luck on your path to becoming a data engineer. Well, for now, thank you for watching and happy learning.